done. Alkenes are done. What's left is only alkynes. And alkynes are the second type of unsaturated hydrocarbons. But these alkynes have a triple bond, meaning 4 hydrogens less from alkanes and 2 hydrogens less from alkenes. So they have a general formula which is CnH2n minus 2. And if you put 1, C1, H2 into 1, that is 2, minus 2, 0. So basically you are drawing a C. Like alkenes, we cannot substitute N is equal to 1 for alkynes, as they contain a triple bond. And for a triple bond to exist, 2 carbons are necessarily important. How can 1 carbon have a triple bond with no one? So it does not make sense. Carbon for 1 would not be possible for an alkene and an alkyne. Therefore, a methane simply does not exist. So does a ethane exist? Obviously it does. We've seen it in the previous modules as well. So put N is equal to 2 and you get a formula C2H2 into 2, that is 4 minus 2, that is 2. C2H2. Let's draw it. Don't even worry about the formula. You can just check it later. So carbon, there are 2. So 2 carbons. Alkyne, so definitely it has a triple bond. Since the compound is an alkyne, we draw a triple bond between the carbon. And if you see, after sharing the 3 bonds, definitely only there is 1 bond remaining. So 1 bond for this carbon and 1 bond for the other carbon. And this is how a ethane would look like. So you just have to draw this ethane if they ask for you a structural formula. But what would you draw if they ask you a cross dot structure? So a cross dot structure would simply look like this. Every bond will be substituted by 2 electrons. If it is a carbon, cross. If it is a hydrogen, dot. So cross dot and cross dot. But when I speak about carbon and carbon triple bond, 3 crosses each for every carbon. And a cross dot for carbon and hydrogen. This is how a ethane's electron cross structure would look like. If possible, put the 3 crosses between the 2 carbons, making the carbon look bigger than the 3 bonds. Next is propyne. And how would you draw a propyne? Very simple. N is equal to 3. So C3H2 into 3, that is 6 minus 2, C3H4. You can check that later when I draw this. C3, how many triple bonds? All the triple bonds. Just imagine putting triple bonds in both the places. The center carbon will have not 4 but 6 electrons. Is it possible for carbon to have 6 bonds? Impossible. So therefore only 1 will have a triple bond because only 1 ion and a single bond. So if you see, the first carbon already has 3 bonds. So you draw 1 hydrogen. But what about the center carbon? The center carbon already has 4 bonds. So will you draw a hydrogen? No. But what about the last carbon? The last carbon has only 1 bond. So let's share the rest of the 3 with 3 different hydrogen, making the formula or the structural formula look something like this. And how would you substitute the cross dot structure? Very simple. For every carbon and hydrogen bond, cross dot. For every carbon and carbon bond, cross cross. But there are 3 bonds, so cross 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 cross, 3 crosses for each carbon, and then a cross cross for a single bond. Cross dot for hydrogen, cross dot for hydrogen, cross dot for hydrogen. And this is how the cross dot structure would look like. So N is equal to 4. What are we drawing now? Butene. N is equal to 4. The root word for 4 carbons is but. 4 carbons. Now a beautiful butene would be drawn. A beautiful butane would be drawn. And this butane would look something like this. So carbon has a triple bond with carbon. Single bond with carbon. Single bond with carbon. Now, if the first one has already 3 bonds, draw 1 more. But the second carbon already has 4. What will you do? Nothing. Go to the next carbon. The next carbon has 2 bonds. Draw the third and the fourth. And the last one would have 3 hydrogens. And you check it. C4H6. Butane. Now this butane would have a cross dot structure. What have you have to do? Cross dot for hydrogen and carbon. And cross cross for carbon. So this is what the cross dot structure would look like. I'm pretty sure you got accustomed to it. You could draw any of the 28 formulas which can be asked. Anything like a decane or a nonene or a octane, anything would do. Remember, methane and methane do not exist in nature. See you in the next module.